Today we're going to talk about the law of cosines. You can apply the law of cosines to solve an oblique triangle. Remember, oblique means something that does not have a right angle. For the remaining two cases, when you are given the measures of three sides, so side, 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 or the measures of two sides and their included angle, which is side, angle, side. The law of cosine says if triangle ABC has side lengths little a, little b, little c, so we're looking here, representing the lengths of the sides opposite the angles with measures a, b, and c, so here's the angle measures, then the following are true. A squared is going to be equal to b squared plus c squared minus 2bc times the cosine of a. So I want you to take a look real quick over here. So if I have a squared, so if this is my side that's being squared, then I'm using everything that's across from it. So I'm going to be using this side, and this angle. Actually, you know what? Let's do these in different colors just to show you. So a squared is the one we're using. This is what we're starting with on the left-hand side, and we're using everything that's across from it. So we have b squared plus c squared, and you can do that in any order. You can add in any order. Minus 2 times b times c, and then the cosine of a. Okay, if we didn't want to use a, we could also use b. And if we used b, let's see if we can circle that again. Then what we would do, so if b was the angle that we started with, or the side that we started with, then we would be using c squared, a squared, and the cosine of b. Similar thing goes for if we were using c squared. So if we had c, then we would be using a, b, and c on this side. So basically you're squaring the other two sides and adding those together, subtracting 2 times the product of those two sides, and then the cosine of whatever angle is across. So let's take a look at example 1. It says, when a hockey player attempts a shot, he is 20 feet from the left post of the goal, so that's right here, and 24 feet from the right post, which is right here. If a regulation hockey goal is 6 feet wide, so we know this side is 6 feet, what is the player's shot angle to the nearest degree? So we're looking for this angle A right here. So we are trying to find angle A. So using the law of cosines, we can help us find angle A. Now, if we are trying to find angle A, that's right here, what do we have in order to do that? Well, we're going to need to use the sides next to it, meaning that we're using this one over here as the start. So we're going to have our 6 squared on the left equal to, we're going to square both of these and add them together. So 20 squared plus 24 squared minus 2 times both of these sides, so times 20 times 24 times the cosine of the angle across from the side that we have on the left, which would be the cosine of A. And that's what we're trying to find, cosine of A. Now, the first thing that we can do is we can square everything. So we have 6 squared, which is 36. 20 squared is 400. Plus 24 squared is 576. And then we can multiply 2 by 20 by 24, and that gives us 960 times the cosine of A. Next, we can add these two together. 400 plus 576 will give us 976. So we have 36 equal to 976 minus 960 times the cosine of A. And a common mistake here is that people try to subtract the 976 and the 960, but you can't do that. These are not like terms. This 960 has a cosine attached to it. So our next step here is to go ahead and subtract this 976 from both sides. We have to get rid of it. So we're going to subtract 976 from both sides, leaving us with negative 940 equal to negative 960 times the cosine of A. And then what we have to do to get rid of the number in front of that cosine, we have to go ahead and divide both sides by that negative 960. So if I divide negative 940 by negative 960, I'm going to get 47 over 48. So I have 47 over 48 equal to the cosine of A. And then to get a out of the cosine, then I need to take the inverse function. So I'm going to come back over here. I'm going to take the cosine inverse of 47 over 48, and that's going to be a. So let's pause it for a second and let's plug that into our calculator. And if I round that to the nearest degree, you should have gotten that a is approximately 12 degrees. So the angle, or the shot angle, is about 12 degrees. If you have questions, let me know. Otherwise, go ahead and try this. So pause it now, unpause it when you're ready to check your answer. If you did try this correctly, you should have gotten that a was approximately 47 degrees. Let me know if you have any questions.